Okay, here today the agenda for meeting for today's session is we are going to start with the following thing. First one, we are going to discuss about the functions of Hadoop Daemons. Okay, what are all the functions of name node? Hadoop Daemons in sense we are going to start our discussion with respect to Hadoop 1.x, name node, secondary name node, job tracker, data node and task tracker. And followed with we are going to discuss about how to perform a HDFS read and HDFS write. And followed with how to perform a job execution. What are all the sequence of actions involved in executing a job? Finally, the Hadoop cluster setup. How to set up a single node Hadoop cluster and how to set up a multi-node Hadoop cluster. So these are all the things associated with today's discussions. Okay. So here, first let me start with these Hadoop daemons. As you already aware, so Hadoop is open source which was developed by Hadoop is open source which was developed by Apache Open Source Foundation. Okay. So here the Hadoop, how you can define a Hadoop. Hadoop is a tool which is used for storing and processing what we called as big data. We in our previous discussion itself we have clearly discussed about the differences associated with the RDBMS data and big data. And in terms of this Hadoop architecture has been concerned, there are two things. One is HDFS and second one is MapReduce. These are all the two core entities associated with this Hadoop architecture. Okay, HDFS as already we have discussed stands for Hadoop Distributed File System. Okay, Hadoop Distributed File System. Then MapReduce is a programming model. Okay, a simple programming model using which you can able to do all the business logic in your Hadoop. Okay, if you have a data in your HDFS, assume that you have data in your Hadoop file system. Okay, so if you want to do some program on top of it, the only allowed model is MapReduce model. We have a separate session of discussion for MapReduce. Okay, what this MapReduce will do, the MapReduce will receive an input. Okay, here the input need to be given to the map function. Intermediately, it is subjected to several transformations such as shuffling, sorting, combining, and partitioning. And finally, the output of those transformation is fed as input to reduce function, and we got the final output from the reduce function. Okay, so this is the programming model associated with in Hadoop. Whether it is 1.x or 2.x, we follow this MapReduce programming model only. Now we have some advanced model. Apart from that MapReduce, we have some advanced framework called as Apache Spark. We have a framework called Apache Spark. Our curriculum deals with some fundamentals on Apache Spark. Okay. So here, if you compare MapReduce with Apache Spark is said to be around 100 times faster than MapReduce because of its some unique features. Okay. So once our discussion of this MapReduce has been over, you will have what's the advantage of doing for Spark compared to that of MapReduce. Okay. Then what is file system? You already have a file system. Each and every operating system will have its own file system. Okay, let me take Windows, and the file system for Windows is FAT16, FAT32, and so on so on. If we take a Linux, the file system for Linux is ext2, ext3, ext4, similarly network file system and so on. So the way by which the files and directories are being organized will be guided by the file system. So similarly, being your Hadoop is a distributed server, distributed database environment. You have data distributed across multiple computers that we have already discussed here in our previous session. How a data has been split and how it is going to be stored is going to be discussed in today's session. You already aware the difference between what is distributed and what is the centralized database. If you have 10 terabytes of data, here this 10 terabyte of data will be stored across multiple computers. This is called as distributed database. Okay, so here how to split and how to distribute the data across these computers has been governed by this Hadoop distributed file system. Okay, these are all the core two constituent components of Hadoop. So in terms of its architecture has been concerned, it is a master-slave architecture. As we have already discussed, it is a master-slave architecture. Some computers has been designated as masters. What are all those computers? We have a name node, which is one of the key computer with respect to this Hadoop cluster. That is, if a name node fails, nothing can happen in a cluster. The name node's responsibility is to maintain the metadata information about the cluster. You please make a note. And we have a secondary name node. If a name node fails, under that circumstances, the secondary name node came into help. In recovering the name node, we will have a discussion. And to execute all the jobs under this control, a job tracker will play a key role. The job tracker's responsibility is to control the execution of a MapReduce job in this Hadoop cluster. Okay, so here under slave we have data nodes. These are all computers. Okay, what are all the things that we are listed here? Name node is a separate server. Secondary name node is a separate server. Job tracker is a separate server. Data node is a separate server. Okay, computer. Then we have another entity called as task tracker. It is not a computer, which is a process running on the data. Task tracker, we call it as a daemon, a back process, a Hadoop daemon running on top of the data nodes. Okay, so these are all the constituent components associated with the infrastructure of Hadoop. Okay, so combining all these things, we call it as a Hadoop cluster. We have one master compute, we have one name node. It is mandatory that we can have only one name node, and we can have one or more than one secondary name node. Practically, we will be having only one secondary name node, and we have only one job tracker. It is mandatory that we should have only one name node, only one job tracker, and one or more than one secondary name node. And with respect to data node has been concerned, we will be having multiple data nodes, n number of data nodes. Okay, data node 1, data node 2, up to we have n number of data nodes. On top of each data node, we will configure this task tracker 1, task tracker 2, up to n task tracker. This setup consisting of a master and a slave togetherly called as a cluster, a Hadoop cluster. Okay, so how the cluster will be organized, we are going to discuss in terms of rack concept. Okay, Hadoop cluster is nothing but a cluster is nothing but a group of computers. Okay, a group of computers togetherly united to form a particular task. Here in this Hadoop, we have the above said following computers. If we say Hadoop cluster size is 100 instance, it specifies that we have 100 data nodes. Okay, so the number of data nodes depends upon two factors. One is, as already discussed, the volume of data that we need to store. It is the data node where we store and process data. Okay, the master node will provide the control, which data node we need to store the data, how to process the data, what are those sort of controls, how to execute a job. Those sort of controls will be taken care by the master node, such as name node and job tracker. And if a name node fails, during its recovery phase, we come into the assistance from the secondary name node. Secondary name node help in this perspective. Apart from that, your data storage, to storing of data and processing of data, everything will take place only on the data nodes. Please make a note. Okay, in your RDBMS architecture, your data storage and data processing takes place only on the server. We have already discussed about this architecture of RDBMS. That is a client server architecture. Those people who have already an idea on Oracle like RDBMS, you know exactly what is client server. We have your server where you have your data stored here in this server. We call this server as a backend. Here only you have your data. How a user will interact? The user will interact with the data through a computer called as a client computer. You may have multiple clients, client 1, client 2, up to you may have n clients. Okay, all the user will interact through this client computer to the server. So here the server's responsibility is to store and is to process data. Here only the data storage and data processing takes place, where in your RDBMS architecture. This is the traditional RDBMS architecture. The client simply acts as an interface. Okay, the data storage and processing takes place here only. Whereas here in this case, data storage and processing takes place only on the slave nodes, not on the master. So they are all slave nodes, and these nodes are called master nodes. The master node will only provide the control. Okay, so where to store, how to store, those sort of instructions alone will be given by the master. So where the data is, how to execute the data, this sort of control will be done by the job tracker. But the actual storage and processing takes place only on the data nodes. According to the volume of data that you need to store, according to the size of hard disk size of your data nodes, here the number of data nodes in a Hadoop cluster can be determined. Okay, so these are all the two factors. One is the volume of data that you need to store, and second one, the size of hard disk of your data nodes. For example, you have a data node whose hard disk size is 2 terabytes. The amount of data that you need to store is 20 terabytes. In this case, how the data has been stored? You need to have the following data: data node 1, data node 2, up to you have 10 data nodes. Okay, so this 20 TB has been splitted into small chunk of 2 TB, 2 TB each, and each data node will hold a partial copy of the chunk 2 TB. Okay, this is the architecture of your Hadoop. Okay, so here this architecture is a layman architecture that I am explaining. Actually, you need to have, for storing 20 TB of data in a Hadoop cluster with a hard disk data node hard disk size of 2 TB, you need to have 30 data nodes. Okay, so why 30 data nodes? I will let you know the solution for that answer. Assume, let me start with a small example. How to perform? Okay, you have a file with 192 MB size. You have a file, let me make it a file.txt with 192 MB size. Okay, so here this file, how it will be stored. Imagine you have 5 data nodes in your cluster: data node 1, data node 2, data node 3, data node 4, and data node 5. Okay, here how this file data has been stored in your Hadoop cluster. Okay, this is your data node. On top of data node, you have task tracker. Okay, which is beyond our discussion. Just to make a note, you have n task trackers. Here, the file has been divided into blocks. So, with the block size of 64 MB, this is the default block size for 1.x. Then if it is for using 2.x, the default block size is 128 MB for 2.x. Okay, so if you take a block size, why you are taking block size in terms of MB? If you take a normal RDBMS like Oracle, what is the default block size? The default block size is 8 KB. If you take any operating system, usually the block size will be 4 KB or 8 KB. It will be only in forms of KBs. Whereas in case of this Hadoop, it is in form of MB. Why so? Because since we are dealing with a huge volume of data, okay, since we are dealing with huge volume of data, let me take, if you want to store 1 GB of data, so if the block size is, let me make it 64 MB, how many blocks that you need? A file, let me take a file 1 whose size is 1 GB. The file is divided into blocks of 64 MB size. How many blocks that you need to occupy this file? Can I get an answer from anyone? 1 GB is equivalent to 1024 MB. So here the default block size is 64 MB. Therefore, which is equivalent to 16 blocks. 64 into 16, 6 4 are 24 to 36, 38, 4, 6, 4, 12, 1024. Okay. So you need 16 blocks. If the block size is 64 MB. If you override the block sizes, if it is 2.x, 28 MB means how many blocks? Only 8 blocks alone will be needed to hold the data. Okay. So here, if it is 8 KB or if it is 4 KB, imagine how many blocks that you are in need of. You need to maintain thousands of blocks. Being you are going to handle data in form of terabyte and petabyte. So if you have a block with a small block size, the number of blocks that you need to manage will become a bottleneck. It will be very, very large in number. It is the responsibility of the name node to manage all those blocks. So to overcome the difficulty of the large number of block management, Hadoop recommends us to go for dividing the block into in terms of MB, not in terms of KB. This particular interview question was asked for an architect. Okay, please make a note. Now you have a file.txt whose size is 192 MB. Then being the block size is assumed to be 64 MB, it is divided into 3 blocks: block B1, block B2 and block B3. Top size is 64. What happens if you have a file size of 200 MB? In this case, the file will be divided into 4 blocks: block B1, block B2, block B3 and block B4. The first 3 blocks occupy 64 MB size, and the last block will occupy only 8 MB. So this is the way by which your file will be split. Please make a note. Okay. So with this introduction, let me now start with how the data has been stored here. Okay, you have 3 blocks: block B1, block B2 and block B3. These 3 blocks has been distributed across the stand. We have block B1, block B2 and block B3 in this manner. So only one copy, if we have only one copy. So as already I told, here the Hadoop, the advantage of going for this Hadoop cluster is 2 things. Okay, why you go for Hadoop? So initially we had a discussion with respect to RDBMS, where RDBMS can't able to store and process what we call as big data. Therefore, we have a technology called as the second type of technology is DA, data appliances. We have discussed about the data appliances like Teradata, Exadata, Greenplum, which is a sophisticated hardware with customized software. Okay, so we have a higher end hardware along with some customized software to store and process what we call as big data. But the drawback associated with this data appliances is cost. So to establish this infrastructure itself, you need to invest in terms of crores. Also, all the associated softwares are not open source. You need to pay for paid softwares. Okay. So these are all the drawbacks associated with your data appliances. I also show you how a data appliances will look like. And then to overcome from that, we have a framework developed by Apache open source. This framework is called as a Hadoop. And one of the most advantageous features of Hadoop is cost. It is of very, very less cost. Also because we can make use of a commodity hardware. As already discussed, we can make use of a commodity hardware. The second advantage is all the softwares are open source softwares. The softwares that we are going to make use of in this Hadoop are all open source softwares. You no need to pay for a single rupee for making use of the software. These are all the advantages of going for. So being it is a commodity hardware, what is commodity hardware? You can make use of a computer like i3, i5 or i7 for your data nodes. Okay, if you have this sort of computers, there is a huge being it is commodity hardware, there is a huge probability of the data node gets subjected to frequent failures because of this low cost hardware. Okay, so imagine if you have only one block copy, if this data node is assumed to be failed, let me take this data node is suddenly failed due to some issues. It may be a microprocessor problem, it may be a power supply, it may be a motherboard, whatever may be. Being it is a commodity hardware, there is a huge probability of subjected to frequent failure, and this data node is now assumed to be failed. In this case, out of this 192 MB, we have one block, that is 64 MB of data is occupied in this data node. Remaining two blocks is in data node DN2. So what happens if we have this data node DN1 got failed? This particular block content will be lost. You will lose your information. So is it permissible? It is not permitted. So losing the information is not permitted. So how you can ensure this high availability? How you can prevent from this loss? For this reason, what Hadoop recommends you is you want to maintain minimum 3 copies of your blocks. You want to maintain minimum 3 copies. It is up to your choice. If you want to maintain 5 copies, yes. No, I want high reliability. I need to ensure more reliability. I need 10 copies. That is also possible. No, sir. For me, 2 copies is enough. Yes, that is also permitted. But it is recommended. It is not mandatory. You please make a difference between the recommendation and mandatory. Mandatory in sense there is no way of overriding. If it is recommended, there exists an option to override according to your requirement. That's the key difference. Okay. So here Hadoop recommends you to maintain minimum 3 copies of your block. How these blocks has been stored? Okay, that's what that we are going to discuss in this particular first part of our discussion. Okay, so to ensure the high availability of data, what is high availability of your data? The user should be able to access the data 24/7. Okay, the user should be able to access the data 24/7, 24 hours a day, 7 days a week, 366 days a year. So the data should be made available to the user. Okay, so for this purpose, if you have only one copy of your block and if the data node fails, you can't able to ensure this high availability. This feature is called high availability. High availability is a technical term. Will let us know how to access the data 24/7. So to ensure that Hadoop recommends us to minimum to have 3 copies. Now, if you have another copy, for example, if data node DN3, you no need to worry about. If this data node DN1 fails, no need to bother about. You can able to continue your action by looking into this data node DN3 for block B1. So now we are going to discuss, this is the way by which the data will be replicated. Now we are going to discuss how this data will be stored. What are all the rules and regulations which governs this storing of data that we are going to discuss using a small example. Slide line. Let we make use of a document for a typical Hadoop cluster. These are all racks. You may aware of, you people aware of rack. These are all data node. Each and every one is a computer. Okay, data. You have multiple computers in this rack. Each and all the computers in the rack will be connected to SSH. You have name node, job tracker, secondary name node, then HDFS client. What is HDFS client? It is a computer through which the user will interact with the Hadoop cluster. In Hadoop, you have masters, you have slaves, and if a user want to do any activity, he need a computer. That computer has been termed as HDFS client. Okay, so this is the way by which your data has been stored. Now let me make it. We have data node 1, data node 2, data node 3, data node 4. Similarly, a data node 1, data node 2, you have data node 3, data node 4, rack 1 and rack 2. So I want to store data. This is the architecture. You please make a note. Each and every rack is nothing but a group of computers accommodated on a single location. Okay, advantage of going for rack is space utilization is very less. Okay, if you go for a tower based computer, you need a huge storage space. A rack can accommodate in terms of according to its capacity, you can able to accommodate 16 computers, 32 computer rack like thing. It will minimize the storage space requirement to host our cluster. Okay, so that's the reason why you go for this rack. Here how the data has been stored. So for that we can make use of another setup. Stored. A single computer is called as a node. Here a node may be a name node or data node or job tracker or a secondary name node. So you have a group of computers. This group of computers will be accommodated on a separate rack. Similarly, you may have a rack is a collection of around 30-40 nodes. If this is an example, you have a rack with 1,000, 100, 200 nodes itself. Okay, if you want to make a view of this rack, let me make a view of this rack. Rack server. So this is a way by which you can accommodate your cluster. They are all servers. Okay, they are all servers. You can find these servers can be accommodated in these racks. Server 1, server 2. Okay, so imagine they are all CPU, separate CPU. Within a single rack, you can accommodate. The racks will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like each and every rack, you can accommodate around 20 servers. If you want to accommodate 200 servers within these 10 racks, you can able to accommodate. Okay, it saves the storage space. That is the thing that is listed here in this example. Okay, a rack it will be combination of several computers. Okay, so here each and every rack as of here is connected to a separate switch. A rack will each and every rack, the computer in this rack will be connected to a separate switch, and all these racks will be connected to a common switch. This is the setup of your Hadoop cluster. The administrator responsibility is to set up this sort of clusters. Okay, you have multiple racks. This is the way by which your cluster will be organized. Now we are going to discuss about how to store the data. What are all the process associated with storing the data? So as I already told, the file will be divided into blocks. Okay, the default block size is 64 MB. So 64 MB default and 128 MB for Hadoop 2.x. Okay, the file, how the file is going to be split and how it is going to be stored. That's what that we are going to discuss with a small example. Now, this is our setup, and you want to go store this file. The file 1 whose size is assumed to be 192 MB, consisting of 3 blocks. This is our basic size is 192 MB. How to store this file? Okay, HDFS client is a computer through which user will interact. Okay, so here the file is splitted into blocks B1, B2, and B3. So now my question is, assume these are all data nodes. Okay, data node 1, data node 2. Okay, let me take each 3 data nodes. Data node 3. Similarly, data node 1, data node 2, and you have data node 3 data nodes in each and every cluster. Now you have a file 192 MB file divided into 3 blocks: block B1, block B2, and block B3. First, my question is block B1, block B2, block B3. So, okay, it is permitted. So, what Hadoop recommends us? So, to maintain high availability of your data, Hadoop recommends you to have minimum 3 copies. My first question is, can I have a copy of block B1, 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 all the 3 copies on a data node DN1? Similarly, can I have a block B2, block B3, again block B2 in this manner? Now I have 3 block B1 and how I am having block B2 2 times and block B3 in the following manner. Is it permitted? The answer is no. Why so? Because why you are instructed to maintain 3 copies? If one data node fails and you need to access the data from other data nodes. If you have all your 3 copies in a single data node, if the data node fails, even though you have 3 copies, you can't able to ensure this high availability. Therefore, the first condition associated here is you can't have more than 1 copy of a single block on a particular data node. No block can have 2 copy on a same data node. Please make a note. No 2 block, that is you can't have B1, B1 2 times in a node. Okay, the only you can have B1, B2, B3 in a single computer, that is permitted. But a block can have only 1 copy on a one node. That is the first condition. My second question is, okay, now I am having a 3 racks. Here my setup block B1, B2, B3, block B1, B2, B3, block B1, B2, B3. Sir, is it permitted? Once again, if you look into this setup here, all these computers in this rack 1 will be connected to a common switch. Okay, if this switch fails, what happens? You have multiple computers and all the blocks, 3 copies of the blocks has been accommodated here itself. If you have this particular switch got fails, what happened here in this case? Then you will lose all your data. You can't able to ensure high availability. So what is recommended is, so you minimum your blocks need to be spawned. That is, your blocks need to be stored across minimum of 2 racks. That is the recommendation. You need to have minimum another copy of the block in a separate rack. Now you have a block copy B1, B2, B3. It is a distributor B1, B2, B3 in this manner. Now it is permitted. Why so? Because a condition satisfied. Now you have block B1 stored in node 1 of rack 1 and also you have block B1 stored in node 1 of rack 2. So it is now spawned across a minimum of 2 racks. So these are all the 2 constraints that need to be followed while writing a block in this data nodes. Please make a note. With this introduction about what is a block and what is the size of the block and how the block is replicated, what is the condition that you need to follow, let me move further of discussing how a block write activity will be taking place. So before going into that, let me have a small discussion of what information will be stored in the name node. Okay, first let me start the discussion of name node. What is the function of name node? The name node is the master node. Okay. How many name nodes that we can have? We can have only one name node in our Hadoop cluster. The thing that we are talking here is Hadoop 1.x. So what is the role of the name node? The name node maintains the metadata information about the cluster. What is metadata information? The data about the entire cluster will be managed by the name node. Okay, you have name node, you have secondary name node, you have job tracker. So the entire metadata information. For example, if you take this information of file.txt, the metadata associated with this, the file is created by the owner Raman. The file, the size of the file is 192 MB. The file is divided into blocks. The number of blocks to which the file divided is 3. Where the block has been stored, the block B1, B2, B3. You have a second copy B1, B2, B3. You have third copy B1, 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 B2, B3. Okay. So this is the way the block is said to be organized. For example, here the metadata contains block B1 has been stored under data node DN1 and data node DN3 and data node DN4. Similarly, you have block B2. Block B2 is stored under once again data node DN1, data node DN2 and data node DN4. And block B3. the block B3 has been stored under data node DN1, data node DN2, and data node DN4. Okay, so these are all the metadata informations associated with these particular blocks. Okay, so who will manage this information? The name node will maintain these informations. Where the name node will manage the information? The name node will manage the informations under two files. What is the name of the file? One is fs image, another one is edit log. These are all the two files under which the name node maintains the metadata information. Where it will be stored, whether in hard disk or RAM memory, this metadata information will be managed in the RAM memory of the name node, not on the hard disk. Okay, so then the secondary name node will maintain a copy of the latest metadata information in its hard disk. I will let you know how it will retrieve and how it will store. For your information, the metadata information is managed by the RAM memory under the name node. The name node doesn't hold a copy of the metadata information in its hard disk. Actually, the metadata information's copy will be managed under the hard disk of your secondary name node. What are all the things that I am conveying? All are interview questions. So please make a note. Why it is architected in such a manner that the metadata informations, rather than storing in a hard disk, is assumed to be managed in the RAM memory. Why so? Because in your Hadoop cluster, each and every computer, whether it may be a secondary name node, or it may be a job tracker, or it may be a data node, or it may be HDFS client, will post frequent request to the name node. The name node, whenever it receives a request from these opposite computers, immediately it need to give a response to the request. If the data is managed under the RAM memory, then it is very easy for the name node to go into the data as far as the request and give back the information back to the requested people. So if the data is maintained in this hard disk, then it need to fetch the data from the hard disk and it need to place the data into the RAM memory, and it will be a time consuming process. So it will affect the overall cluster performance, and in taking into these sort of things into consideration, in order to overcome from degradation of a cluster in terms of its performance, it is architected in such a manner that the metadata information is maintained in the RAM memory. This is again an interview question asked for an architect in Accenture. Today and tomorrow you are working for a Hadoop admin and Hadoop developer for Accenture. If any one of your friends already aware of this technology, kindly let me know. I will give you a contact detail for Accenture. Around 40-50 plus openings are there. Minimum salary, a guy with around 3 to 4 years of experience is ensured 75,000 to 1 lakh monthly salary. Okay, so this is the way by which the name node maintains the metadata. These are all some of the sample metadata. So the name node maintains the metadata under these two files. File name is the first image and edit log. So the information here regarded log B1, the owner RAM, file size 192 MB. Okay, these sort of information will be managed under this FS image file. Initially, the edit log will be empty. If there is a change in the cluster, then in that case, those changes in the cluster will be recorded in the edit log. Please make a note. Originally, when you start the server and all the information associated in this cluster as a metadata will be managed in FS image. If there is a change, this is the setup here. Okay, example. Let me imagine that this data node DN3 got failed. What happens here in this case? So Hadoop recommends us to maintain minimum 3 copies of block B1, block B2 and block B3. Now if a data node DN3 got failed, what happens? Instead of 3 copies, now we have only 2 copies of our block B1. It is not at all allowed. So this scenario of having 2 copy instead of the default 3 copy is called block under replication. Block under replication or under replicated block. Please make a note. Block under replication or under replicated block. What is the drawback? So instead of having a recommended copy, we have minimum copies. How a name node, what provider, how a name node came to know that this data node got failed. Okay, the name node, how it will know means all the data nodes in the cluster for every 3 seconds once, all the data node in the cluster send a heartbeat signal to the name node. This is again an interview question. The duration is for every 3 seconds once, all the data node will send a heartbeat signal. The heartbeat signal indicates that, hi name node, I am data node DN1, I am live in the cluster. Okay, you can use me at any point of time. These are all the informations associated with the heartbeat. Okay, if a name node doesn't receive a heartbeat for 9 seconds, continuously for 9 seconds from a data node, it assumes that the data node got failed and it will mark it as a failed data node. Okay, once it is marked it as a failed data node, what the action that it will initiate is, it will immediately look into the metadata information, of the data node. Now the block B1 is assumed to be in this data node DN3. Okay, now the data node DN3 containing block B1. Therefore, instead of having the default copy of 3, now we have only 2 copies, which is not at all recommended. This scenario is called under replication, block under replication. You need to make it once again back to 3 copies. What the name node will do is, it will look into the other node which holds the copy of this block B1. Now in this case, block B1 is assumed to be in data node DN1 and data node DN4. It will contact any one node. In this case, let me imagine it contact data node DN1. Data node DN1, it will send the instruction to data node DN1. Data node DN1, you are having a block B1 belonging to file.txt to please copy the block into data node DN5. What is the possibility here? You can have a block copy either in data node DN2. You can't have a copy here in data node DN3 because of its failure. Again, data node DN4 also you can't have a copy. Why so? Because you have already a copy of block B1. If you try to copy block B1 again, it is a violation. You can't have 2 copies of a same block in a single data node. Therefore, the only possibility here is data node DN5. So the name and data node DN2. The name node will instruct the data node DN1. Data node, you please make a copy of your block B1 either in any one node. Let me assume that it is now is assumed to be in it is now copied in block B2. Okay, so block B1. Now then block B1, now we have this data node 1, and instead of this data node 3, now we have a new copy in data node DN5 and the third copy in data node DN4. This change, because of the change in cluster, that block B1 is not now present in data node DN3. Now it is occupied under a new data node DN5. This information is recorded in the edit log. Please make a note. If there is a change in cluster, those informations will be recorded in the edit log. The initial setup related information will be managed in the FS image. Please make a note with the example. I request you all to take notes. Whenever I take classes, you want to take notes. Even though I share this recording, I couldn't able to share all the recording. I will share some recordings only, and the majority of the key recordings won't be shared to you. The use cases associated things. Okay, so you want to take a notes. It is requested to do so. Is it clear for? Once again, we have discussed about the name node, functionality of name node. The name node function is to maintain metadata. So here the problem associated with Hadoop 1.x, if a name node fails, what happens? You can't do any activity in your cluster. Your cluster will be down. Even though all other computers are working fine, you can't able to do any action if a name node fails. This is problem is called as name node single point of failure. What happens? How to resolve these issues? Here the issues can be resolved in Hadoop 2.x by having multiple name nodes. One we call it as a primary name node, another we call it as a standby name node. Both the name node will receive the metadata informations. If a primary name node fails, no need to worry about. Immediately the standby name node will take the charge of your cluster. By the way, you ensure high availability of your cluster irrespective of failure of your name node. This is called as name node high availability. We call this feature as in two context name node high availability. Please make a note. So this is the one of the greatest advantage of Hadoop 2.x compared to that of Hadoop 1.x. Now we are discussing with Hadoop 1.x. Once our discussion on Hadoop 1.x has been over, we move on to Hadoop 2.x. Okay. So now we are going to discuss about the secondary name node, the functions of secondary name node. What is the role of secondary name node? Okay, as you told, name node maintains the metadata information in its RAM memory, and RAM being it is a volatile memory. Volatile in sense the content, the data will be present until the machine is running. If the machine gets down, okay, all the data will be erased. The data will be erased. Okay, so that is the volatile. You know, if a machine got down, the information present in the RAM memory will be erased. Let me assume a name node file, and during its recover phase, the RAM memory will be empty. There won't be no metadata information. If that is the case, name node 2 doesn't know what to do. How many data nodes are there in the cluster? Where the files have been stored? Who can able to perform a read or write into the file? Those sort of information is not unaware to the name node. Why so? Because the metadata information, it lost the metadata information. Under that circumstances, what happened here is the secondary name node will come to the rescue. The secondary name node, what it will do, it will usually for every, this is again a default, every 1 hour once, it will contact the name node and it will take the metadata information and it will store the metadata information in its hard disk as a backup copy. It will maintain a backup copy of your metadata information in the hard disk. So if a name node fails and if during the recovery of the name node, the secondary name node what it will do, it will take this backup copy of the metadata and it will place the backup copy into the RAM memory. Once the backup copy is placed in the RAM memory, the name node will read into the particular metadata information and it now come aware what is the status of the cluster, how many data nodes are working fine, how many users are stored files, what are all those files, what is the size of those files, under which data node the files data has been stored. Like all the informations will be known to the name node and name node now take the control of the cluster. So this is the role of secondary name node. Okay, there is no other option. If a name node fails, your cluster will get crashed. So you need the help of secondary name node in this perspective. Please make a note. A secondary name node, for every 1 hour once, it will take the metadata information from the name node and it will take a backup copy. Now we are going to discuss what are all the things the secondary name node is going to perform. You have name node, you have FS image, you have edit log. Let me take the same example. The first image, block B1 is assumed to be initially in data node 1, data node 2 and data node 3. Now the block B1, because of failure of data node D and 3, now it is stored in data node 4. This is the information in edit log. What this secondary name node will do? The secondary name node will fetch the information. Okay, this FS image and the edit log. It will fetch the information and it will make a update. Okay, it will read the edit log. It will read the edit log and update the information into the FS image. Therefore, now the FS image will have block B1 stored in DN1, DN2 and in DN4. Yeah, updated FS image, that is a new FS image. This is the old FS image maintained by the name node. The secondary name node, it will fetch the old FS image and make an update to the old FS image. It will update the information from the edit log and it will create a new FS image. Okay, and the new FS image contains the updated information. Now you have block B1 stored in data node DN1, data node DN2 and data node DN4. Now what it will do, it will send back this new FS image to the name node, replacing the old FS image. Now the name node will have a new FS image and the edit log will be cleared. Okay, edit log will be cleared. Edit log also be empty. A new FS image will have the following information. Also, it will maintain this new FS image as a backup copy in the hard disk. This event happens every 1 hour once by default. Once again, if you want to make it happen every 10 minutes once, you can make it. I will let you know under which configuration files that you need to go for this purpose. Okay, so this is the way by which at any point of time a secondary name node will have the latest metadata backup of the name node. Therefore, if a name node fails and if again during the recovery phase, it will take the backup copy and it will be placed in the RAM memory. So by looking into this information into the RAM memory, the name node will know what is the status of the cluster during this recovery phase. This is the function of secondary name node. Please make a note. This is the function of secondary name node. Okay. Now you know what is the function of name node. You know what is the function of a secondary name node. Now we are going to discuss about this job tracker. What is the function of job tracker? The job tracker's responsibility to execute the job. Before going into the discussion of job tracker, let me discuss how to perform a HDFS read and HDFS write. That means how to write the data in HDFS and how to read the data from HDFS. Okay, after that we can go for a discussion on job tracker. So now you have a block file. The similar example. File F1 whose size is 192, assumed to be 192 MB, divided into blocks. So here the user will submit a request. This is your Hadoop cluster. This is your Hadoop cluster. The user want to store the file. What the user will have? The user will have a file. User will interact with this Hadoop cluster through a computer called as HDFS client. The user will submit a file. Okay, file F1. What happened is first the HDFS client send a request to name node. Name node, I am having a user by name Ram who want a file whose size is 192 MB, who is divided into 3 blocks, need to be written in the data node. Please kindly let me know the data node, list of data nodes to write this copy. First, the request is for block B1. The HDFS client send a request for block B1, a create request. The name node, what it will do? It will do 2 things. One, it will look whether the user RAM is having access permission to write a file into this Hadoop file system. Second, whether the file as per is file 1 is already present in the HDFS or not, present or not. If you have already a copy of the file in HDFS, no need to write again. So therefore it will check the following condition, whether the user who is submitting the request is having a write permission, and also the second condition that it will check is whether the file is present or not. If both satisfies, the file is not present, user is having access permission, what it will do? The name node send a response by replying the data node DN1, data node DN2 of rack 1 and data node DN1 of rack 2. So these are all the list of data nodes. You can store the block B1. This is the information sent by the name node. Okay. So under this, before sending this information, name node will take care of the rack awareness under which data node we have this over block B1. Already if you have a block B1 in other data node, it should not copy it there. So these sort of information will be considered by the name node before deciding which data node the block need to be copied. Therefore, the name node's responsibility here is it will decide the data node under which the block B1 need to be copied. The HDFS client, when it receives this request, what it will do? It will take the first copy and it will place the first copy in this. For example, let me make it data node DN2 and data node DN3. Okay, data node DN2, data node DN3. It will take the first copy in the data node DN2. Also, it will send this following list of data nodes that it receives from the name node to the data node DN2. Data node DN2, what it will do? It will mark, okay, my first copy copied in data node DN2. It will look into the other data node. Which data node need to be copied? Now we have in the list data node DN3. Now it is the responsibility of data node DN2 to make the second copy of the block B1. Okay. Also, it will forward the list of data nodes that it receives from the HDFS client. The HDFS client receives the information from name node. From the HDFS client, it sent to the data node DN2. Data node DN2, once it make a copy B1, it will forward, it will write the second copy of block B1 into data node DN3 and also it will send the request. Now, you need to have the third copy to be placed in data node DN1. Who is responsible? Data node DN3 will make a third copy. Once all the three copies are successfully written, then acknowledgement will be sent. Data node DN1 send acknowledgement to DN3. DN3 will send acknowledgement to DN2. From DN2, the HDFS client will receive acknowledgement. If it receives 3 positive acknowledgements, then the HDFS client will make a note that a block B1 is successfully written into the HDFS. Then that information will be recorded in the name node. Name node, I send a request for you, requesting for list of data nodes to store a block copy B1. As per as my request, you send me some information regarding under which data node that I need to maintain. I had successfully written that block B1 copy to all the data nodes. This is the way by which a block B1 will be written. Similarly, a block B2 and block B3 will be written, and all the information, once it is successful or if it is a failure, will be recorded in the name nodes metadata. This is the way by which you will perform writing activity into the HDFS. If you have any doubt in this perspective, I will let you know with the diagram. Now, HDFS client send a request. The name node, once it receives the request, what happen? It will check, okay, whether the file is already exist and client is having permission to write the file. If it is okay, then name node will send a list. According to the list, HDFS client will make a first copy of the block B1 in data node DN2. Now the data node DN2 will make a second copy from this portion to data node DN2. Then this data node DN1 of rack 2 will make a third copy. Now you have 3 copies of the block. Now similarly, you will receive acknowledgement in the reverse side. Data node DN2 to data node DN1, and from data node DN1 to data node DN2 of this rack 1, and from data node DN2 into the HDFS client. Here this acknowledgement and writing, being it is similar to that of a pipeline, we call this as a pipeline write and pipeline acknowledgement. It is an interview question. Please make a note. You have block B1 from here to here, from here to here, from here to here. Similarly, you receive acknowledgement in the reverse side. From here to here, acknowledgement is reverse. Here to here, and from to here. This is called as pipeline write and pipeline acknowledgement. Okay, make a note, please. Okay, so this is again an interview question. So this is the way by which you will perform a HDFS. Similarly, for all the blocks will be written. If you want to make a read, again the HDFS user will submit a request to read a data into this HDFS client. HDFS client send a request to name node. The name node will check again if the file is present, already file is present, the requested file is present. and the requester user is having access permission to read the file. If both the thing okay, the name node audit will do once again send the list. This is the list data node DN2, data node DN1, data node DN2 of rack 2 and rack 1. Here the block B1 has been stored. Then the name node what it will do, once it send the information to HDFS client can able to read the data from any one of the data node. Nearest data, it may be this data node or it may be this or this. From any one data node, it will read the data and it will do the needed activity. Okay, this is the way by which HDFS write and HDFS read will takes place. So with this, now we are going to move on to the discussion on the functions of a job tracker, how a job execution is going to take place. And once our discussion has been over, we will start what is Hadoop cluster and how to establish a Hadoop cluster in the next half. Now it is time 10:14. Now you can go for a break of 15 minutes and you will be back at 10:30, and we have a session from 10:30 to 11:30. The second half is going to be discussed about the function of job tracker and the installation part associated with your Hadoop cluster. Okay. If you have any doubt in this perspective, kindly let me know. Not now. Okay, now we are going to start the discussion on how a job execution takes place. For example, a job execution is nothing but executing a MapReduce job, running a MapReduce program. This MapReduce program can be written using programming languages like Java or Python, etc., Perl, Ruby, etc. Or we can make use of these two components coming with Hadoop. One is Hive and Peak. Tomorrow we are going to start the discussion on Hive. Okay. So here a user will have a program. You want to MapReduce program. So here these are all the data that is associated with the programs. The data has been stored in data nodes. And you have task tracker here, task tracker 1, task tracker 2, and n number of task trackers. And here you have a name node and you have a job tracker. A user will submit a program through this HDFS client. Okay. Through this HDFS client, user will submit a MapReduce program. So what happened here in this case? The user request first forwarded into the name node. Okay. You have the data for this program here. The user's request will be forwarded to the name node. It will request a name node. User, let me again take an example of Ram. I want to run a program. The program name is some XYZ program. He need the data for the program. Kindly allow the user to let him know where the data for the program is present. Like the information will be submitted through HDFS client to the name node. The name node will look once again into the metadata whether the user RAM is having a execute permission. Okay, to access the data stored in HDFS. This is for HDFS. User RAM is having a execute permission. User is having execute permission instance. It will assign a job ID for the particular task and allow the user to continue his activity. Then the HDFS client what it will do, it will then once it receives, then it also intimate to the job tracker. Job tracker, the user RAM is going to run a program. The job ID is A01. Okay, the program is going to access the data under the following data nodes. Let me make data node DN1 and DN2 holds the data that is needed for running the program. So these are all the informations sent by the name node to the job tracker. Okay, now the job tracker is aware the what job that is going to be executed, and where to look for the data for those jobs. In this example, it is assumed that data node 1 and data node 2, let me make it block 1 and block B2, under which the program need to be run where needed data is present. Okay. So once it receives the information, the HDFS client, what it will do, it will simply copy the program into the HDFS in any one of the data node or in a name node, whatever it may be. Probably it will be on the data node. It will copy the program. Let me make it is 1.java. The program will be copied into the data node. Okay. Now what happened? Who will copy the program? So here the particular HDFS client will give the program to the job tracker. The job tracker what it will do? Already it will know where the data for the program is present. Under this case, we have two nodes. One is data node DN1 and another data node DN2, which holds the data for the program. Therefore, it will copy the program 1.java to both data node 1 and data node 2. Okay. So, and the program control will be given to the task tracker. It will convey the task tracker of the associated data nodes task tracker. Here I will be submitting you a particular program. You run the program on top of the particular data block. Then according to the instruction that it received, a task tracker what it will do, it will start a JVM, Java Virtual Machine. Okay. And the JVM starts its execution of a map task or reduce task on top of the block where we have the data. So once all the, for example, in this case, we have only two data nodes. Therefore, we have two copies of 1.java running by the associated task trackers on top of the data node 1, data node 2. Once these two job tracker finished executing the task, and the result will be given back to the task tracker, job tracker. Okay, the job tracker will receive the request, and the job tracker will inform the name node the particular task is successfully completed, and the result will be given back to the user. Okay, this is the way by which a job execution takes place. Okay, so here in your traditional approach, you have your server under which your application will be running here. Application is nothing but, imagine a program is running here, application program, and you want to move the data into the server for processing. The data need to be moved into the server. Whereas this is your traditional approach of doing a task execution. Okay. So your application will be rigid. The data will be in motion. It need to move to the server where you are running your application. Whereas here in this approach, this Hadoop approach, what happened here is your data will be residing in the data node 1, data node 2. You have data residing here. Your application, your program alone want to move to the location where you have your data. Why? Because for doing a particular MapReduce task, you may need to run a program which may runs to 100 or 200 lines of coding. Okay, for assumption, let me make it. You want to run a program, write a program which accounts to 100 or 200 lines of coding. Whereas your data, imagine your data is in forms of terabyte and petabyte. Each data node, let me imagine, contain 1 lakh records. So if you have 1 lakh records, whether moving this, you have your program here, let me make it is in job tracker. If you want to move the 1 lakh records into the job tracker is easy, or moving 100, 200 lines of program into the data node is easy. Option 2 is easy. Moving 100 or 200 lines of the program which is running on top of this 1 lakh or 2 lakhs of records stored in data node will be easy. And because of this huge involvement of a huge volume of data, it is orchestrated in such a manner that rather than following a traditional approach of moving the data into this particular application server, here the application, that is your program, will be moved into the server where we have your data. You please make a note of this architecture. Okay, so this is the way. Here all the data will be executed in parallel. For example, if you have this 5 data nodes, if you imagine you have 5 data nodes, data node 1, data node 2, data node 3, data node 4 and data node 5. Each data node, let me assume you have 1 lakhs of records. Okay, corresponds to our program. We have 3 data node contains the records. The Java program size is let me make 150 lines of coding. What happens is this program will be sent to the job tracker, and the job tracker will copy the program in the corresponding data nodes. We have this one.java program copied on all the location where it need to run. Okay, so each and every Java program will run on top of this 1 lakh records. Okay, it will run on top of the 1 lakh record, and each output, each 1 lakh record will produce a partial output. Then all these output has been clubbed to form a final output. Okay, here all the task that is running is concurrently. You can do concurrent instance parallel execution because of the way of executing the job in a parallel manner. So by copying the corresponding programs code into the appropriate data node, you can able to achieve very high performance in its execution. This is called the parallel execution, or we call it as a distributed data processing. So because of the way of applying this concept, the execution time has been reduced to a great extent. That's the advantage of going for this parallel process. We call this as a concurrent processing, parallel execution, or parallel processing, anything as you like. So this is the logic behind this execution of a job in a Hadoop cluster. Okay. So here for storing your data, who are all involving? For storing data, you involve name node and data node. For executing a job, you involve name node, job tracker node, and task tracker. So these are all the daemons and the functions associated with the Hadoop context. Okay. Now we have completed our discussion on the functions of name node to maintain the metadata. The functions of secondary name node will help the name node when it got failed during its recovery phase by supplying the metadata. The function of job tracker to execute the job. The function of data node to store data, and function of task tracker. Again, on behalf of the job tracker, task tracker will do the job execution. Okay, so these are all the associated functions of the Hadoop daemons with respect to Hadoop context. Okay, so now we move on to the discussion of the Hadoop cluster. Hadoop cluster and its installation. So now, in terms of this Hadoop cluster has been concerned, with respect to the size of the cluster, we can categorize the cluster under the three categories. With respect to the size of the cluster has been categorized under 3 categories. One is a small cluster, second one is a medium cluster, third one is an enterprise cluster. A small cluster, medium cluster, and an enterprise cluster. If you have data nodes in terms of tens, 20s, up to hundreds, the size of the cluster depends upon the number of data nodes in the cluster. Based upon the number of data nodes only, we specify the size. If the number of data nodes are 10, 20s, 30s, like up to hundreds, it is coming under a small cluster. If it is 100, 200, like up to thousands, then it is called as a medium cluster. And beyond 1000, if you have beyond 1000 data nodes, those cluster has been termed as enterprise cluster. Okay, here I want to convey one thing. The advantage of Hadoop is low cost in terms of hardware, and in terms of software, being it is open source, no cost. These are all the advantage. Okay, so in terms of low cost, we have discussed about making use of this commodity hardware. So the commodity hardware means low cost hardware. Can I have a commodity hardware for my servers, name node? Can I have a commodity hardware for my job tracker? I can have a commodity hardware for my data nodes. So what is the drawback associated with commodity hardware? If it is a probability of a frequent failure, we can't able to predict at what time node will fail. Okay, no issue. If I have failed, my data node got failed. and the block B1 is being replicated on another data node, it won't have any influence. Okay, I can continue my reading or writing through the data node DN2. So there won't be any impact if there is a failure of one or two data nodes. So in that circumstances, we may have a commodity hardware for the data nodes. Imagine a scenario in which your name node get crashed. You have a commodity hardware for a name node. So you have a 100 node cluster. All the data nodes are running for working fine, and job tracker is working. But if a name node fails, you can't do any activity on the cluster. So because of the reason, what it is recommended is, so your master computers should not be configured with the commodity hardware. Rather than your master computer need to configure with a little bit high-end servers. Not a server in terms of crores. You need to have a replica of each and every component in terms of lakhs. You may have a server with 3 lakhs, 2 to 3 lakhs for name node. You may have a server for again 2 to 3 lakhs for job tracker. Like for your master, it should not suffer from any single failure. Yeah, failure of RAM or failure of hard disk should not have influence in shutting down the server. It should have a replica of the component. It should have two processor. It should have two RAM. It should have two power supply. That is redundant hardware need to be present in the server in order to ensure the high availability of the server. Okay. So in this case, let me imagine you have purchased a server of 3 lakhs, 3 lakhs, 3 lakhs. Okay, you need to establish a cluster only with 20 data nodes. Is it mandatory that you need to have a separate name node, a separate secondary name node, a separate job tracker for a small cluster like thing? What is recommended? What is the recommended architecture for a small cluster in terms of its master? What is the recommended architecture for a medium cluster that we are going to discuss now? Okay, so here if it is a small cluster, here what if it is a small cluster, what you can do, you have one computer and you categorize name node, secondary name node and job tracker. All the thing can be configured on a single server itself. If it is 10s or 20s. Okay, if it is a 10s or 20s, you can have all the thing configured on a single server. It is not mandatory. If you have enough budgeting with you, you can have a separate server. It is up to your choice. If it is a medium, it is recommended a name node and a job tracker need to be configured separately, and a secondary name node need to be configured separately. So these are all your data nodes. If it is a enterprise, here it is recommended to go for a separate name node, a separate secondary name node, a separate job tracker. So this is the recommended architecture. Even if you have a 10 node cluster, if you have enough budget, you can have a separate computer. That is not a problem. Okay. So this is the way by which you can able to reduce the cost with respect to this the number of servers that you need to configure. A minimum recommended configuration is for server. You just make a note of this. If you can have for your master, you can have a Intel Xeon core, Intel Xeon server. Okay, it may be a 8 core or it may be a 16 core server for your masters. Whether it is a name node or secondary name node or job tracker, it is recommended to go for minimum 128 MB of RAM. Real time setup, 128 MB of RAM. And you may have a hard disk of around 6 GB of hard disk. Hard disk requirement is minimum here. You need only operating system to be stored on the master. The slave configuration is, you can go for if it is Intel Xeon, you can go for a 2 core, or you can go up with Intel i7. The minimum RAM memory in your data node is 32 or 64 MB RAM memory. And each data node can have a hard disk of up to 4 GB. Okay, so this is the hardware architecture associated with the masters and slaves. Even it is an industry setup. You can even establish your cluster. If you have i3, you can also establish a cluster with the i3, no issue. Now what we are going to do, we are going to establish a cluster using a virtualization only. We are going to make use of VMware workstation for our establishment of cluster. Even a single machine is sufficient enough that you have. Okay, this is the or some of the basics associated with the types of Hadoop cluster and the way by which you configure a cluster and the configuration informations in terms of how much of RAM, how much of processing capacity and how much of storage is needed. Do you have any doubt in this regard? Kindly let me know before proceeding further. Please. I need a quick response. Is it okay? I am making sense with my presentation or you have any doubt? In terms of number of machines has been going to be configured, we can configure a single node cluster or we can configure a multi-node cluster. Single node means you will be having only one computer. Under the computer you have name node, secondary name node, job tracker, data node and task tracker. Everything will be configured on a single computer. A multi-node computer instance, you have two things. One is pseudo distributor cluster. Another one is fully distributed cluster. In pseudo distributed, you have a separate machine or a configure. We can club according to our previous discussion. Imagine you have a name node followed with multiple data nodes. But all the here too you have a fully distributed also the same sort of setup. You have a name node, you have a secondary name node, you have a job tracker, and you have a multiple data nodes. These are all data nodes. Then what is the difference between a fully distributed and pseudo distributed? In fully distributed, all the computers are physical computers. Here you can form a cluster using virtual machines, logical computers. Okay. Here the concept that we are, the technology that we are going to apply is virtualization technology. The software that we are going to make use of is VMware Workstation, or we can go for Oracle's Virtual Box to set up a pseudo distributed. Okay, all the computer can be configured on top of a single physical computer. You have single physical computer. On top of the physical computer, you will have a virtualization software. Using this, you can configure a logical computer called as virtual machines. Okay, this is the way by which a pseudo distributed and a fully distributed cluster differs by. Now we are going to discuss about the concept of virtualization. Okay, so single node, this is for meant for learning purpose. You can't use in the production. This is the setup multi-node you will be using in the production environment. In real time, you go for either a pseudo distributed or a fully distributed cluster. You can get this pseudo distributed cluster either using virtualization or you can get this from any cloud service, from a public cloud or from a private cloud, any cloud like Amazon, Azure, or you can get it from OpenStack. So these are all the ways by which you can, based upon the number of computers, you can categorize your cluster. And another thing, so in our curriculum of Hadoop administration, we are going to install our Hadoop cluster under the following ways. You can configure the cluster one, either using a physical computer, separate computer, or you can go for this virtual computer, VMs, using this virtualization softwares. Okay, so or you can go for the computer from cloud. Here we are going to make use of Amazon AWS for our setup. So these are all the three environment under which you can establish a Hadoop cluster. So all the steps, whether it is a physical computer or virtual computer or cloud, almost 98% are similar thing. Only it differs by 1 or 2% according to the configuration that you need to make. That's all. Okay. Now we are going to start the discussion on how to install, what are all the associated softwares. We are going to discuss about how to configure a Hadoop single node Hadoop cluster, and what are all the softwares and sequence of installations that we need to do in order to establish a single node cluster is going to be discussed now. Okay, here the minimum requirement of your hardware is, it is recommended to have minimum i3 with 4 GB of RAM. Okay, so here what we are going to do first, this is our setup. Let me make it to i3 4 GB of RAM. First you need to install a virtualization software. On top of it, you can go for this virtualization software. Either you can go for a virtual box of Oracle, or you can go for a VMware. Okay, VMware workstation. So here we are going to follow this VMware workstation version 11 or version 12. I will share you the link where you can download this VMware workstation. Okay, you install this VMware workstation, and using that you need to create a virtual machine. In the virtual machine, you are going to install the following operating system: Ubuntu 14.04. The virtual machine contains 2 microprocessor and 2 GB of RAM with a 20 GB of hard disk. This is your hardware, and this is the software that you are going to. The operating system is Ubuntu, and we are after that what you need to do. This is step 1. You need to create a virtual machine. Then with the following hardware configuration, minimum of 2 microprocessor or 2, that is minimum recommended, and you can configure Ubuntu 14 or Ubuntu 16. It is up to your choice as your operating system. After that, what you need to do, you have a either if you have a Ubuntu machine, directly you can install. You no need to go for the concept of virtualization. If your desktop or if your laptop is equipped with Ubuntu, you can straight away install all those things straight away. Okay, once your machine, during this installation of Ubuntu, it prompts you for a username and password, and I request you to go for a username Hadoop and a password Hadoop. Username and password need to be of Hadoop. Okay, it is not mandatory. You can have your own username and password. For the first time, you kindly follow as per as my request. Okay, now after installation, what you need to do, so you want to start the VM. It prompts you for a username and prompts you for a password. You want to type just username Hadoop and password Hadoop, or else you want to configure username password. It will take you to a graphical user interface of Ubuntu. For your configuration, you want to switch over to command line interface. The command is Control plus Alt plus T, terminal. Please make a note of all these commands. You once you get into this game mode, to let you take to this command line interface, Control plus Alt plus terminal. Okay. So what are all the things that I am going to discuss are Linux commands. Installation is will be a Linux based command. I think so. You are aware of Linux. Okay, sir. Kameshwar, do you aware of Linux? Basic Linux.
Little I know.
Okay, today I will share some videos for the past batch and the current batch. The video will be coming from another link, not from Raman GS. It will come from another new link. You just go through those videos. Okay.
Okay.
Yeah. It will take you to the command prompt. Then what you need to do, you want to install the following. The first command that you want to use is sudo apt -get update. So it will update the needed software. Then you need to install Java. Sudo apt-get install open jdk -7 -jdk. It will install Java in your computer. it will install Java. Where it will install Java? Under user lib JVM. You have a Java installed here. Okay, this is the path where you have installed Java. Default, this path will be chosen here. User lib JVM. You have your Java under which you have your bin folder. Everything will be here. You please make a note of this path. You want to specify in a configuration file. Then after that, the installation has been over. You need to install a sudo apt-get install open ssh-server. You need to install this open ssh server. Okay. So once this open ssh server, it is used for authentication purpose. We will have a separate discussion. After that, you want to install apt-get keygen. So you no need to go for the apt-get. This is not a, just type ssh keygen. It will generate two keys. One is id underscore rsa.pub. Another key is id underscore rsa. Where it will be generated under the following location: under home, under Hadoop. You have a folder by name .ssh. Under this, you will be having these two keys. Okay. So these are all Linux commands. I will share you within an hour. I will share you two Linux videos. You please go through these Linux videos and you will have an understanding of what is what. Else I will clarify. Okay. The key generation will be made. And after what is the purpose of going for key generation is to authenticate yourself as a legitimate user. So to make you as a legitimate user without asking a password, you will be let to log in into the Hadoop cluster. For that purpose, you need to do this activity. The important thing is you should not use sudo privilege here. Just ssh-keygen. You want to simply type enter key, enter for all the question. It will create a key. These two keys will be created under the following location. Under home, under Hadoop, you have a .ssh folder under which it will be created. I will show all those things now. After that, what you need to do, you want to copy a key. Sudo SCP. SCP stands for secured copy /home /Hadoop /.ssh id underscore rsa.public key. You want to copy the key under /home, once again under Hadoop, under .ssh authorized underscore keys. Authorized underscore keys. Okay. This is your source where you have this key, and this is the destination where you need to copy the key. This is the name authorized underscore key. Under this is a file. Under this name you want to copy the key. So it is meant for authorization purpose. Then everything, if it, to check it, the command is ssh localhost. You want to land into the login prompt without asking password. It will prompt you yes or no. You simply type yes. It will land it in a prompt without asking password. If it land it in a dollar prompt, and what are all the things that you so far configured is found to be perfect. Okay. Now you need to download and install Hadoop. You want to download and install Hadoop. Where to download Hadoop? From the Apache side. Okay. The command is wget. You want to specify this Hadoop URL. Okay. So here where to get this URL, you can get the URL and there are the following. You simply go for Google and simply type download Hadoop. It will take you to a site Hadoop.releases. Click on. So click from a mirror site here. Download the release from a mirror site. Okay, these are all the current versions. You are going for version 1.2. Therefore, click on this mirror site and go to this URL. You can get any URL. This is the file Hadoop 1.2.1 and the file with the size. This is the what we are in need of. Okay, Hadoop 1.2.1 tar.gz. The size is 62 61 MB. Simply right click and copy the link address. Please make a note. Simply right click, go to the corresponding location, right click and copy the link address. What happened here is now it is assumed that you are in the dollar prompt. If you simply type pwd, it will throw output that /home/Hadoop. You are in the location. So just in this dollar prompt, if you type wget and simply paste the URL. The URL just now you have copied. This is the URL that you have copied. Right click, you have copied the URL. Okay, you have copied the link address, and simply if you simply right click and paste, the link will be formed here. If you simply type download பண்ணி தான் ஆயிடுச்சா அது இல்ல So now what we have so far did is, so you create a VM. You have created a virtual machine. At the time of creation of virtual machine, you have configured Ubuntu on top of it with the username and password as Hadoop and Hadoop. And after that, what you did, you perform an update command, sudo apt up. This is the best practice to go for performing an update before installing any software in any Linux flavor. Sudo apt-get update. Third, what you did, you install Java. Sudo apt-get install openjdk -jdk -7 -jdk. Okay, and step 4. After that, what you need to go for, you have perform installation of sudo apt-get install ssh-server. Open. Then step 5, ssh-keygen will generate 2 keys, and step 6, we have copied the key into the name authorized underscore keys. It is for our legitimate purpose, and we have at the end downloaded the Hadoop. Okay, so the Hadoop will be come under a tar file. The downloaded Hadoop will be under Hadoop -1.2.1.tar.gz. So what you need to do, step, you want to untar it. Tar -xvf. You want to specify the path, else you can specify a full path. Under home, under Hadoop, you specify Hadoop -1.2.1.gz. tar stands for tape archive, gz stands for zip file. So it will successfully untarred, and you will get a folder under the following location: under home, under Hadoop. This Hadoop is a user that you have given. Okay, then this is a username that you have given. And this is, you can give any name, not Adobe, you can give even RAM, you can give even SAM, anything that you like. So under home Hadoop, you will be having a folder by name Hadoop-1.2.1. Under the folder, you have another subfolder bin, and you have another folder conf. These are all the two key folders, okay, that you are going to make use of up to step 7. Okay, now next what we need to do, you want to populate some configuration files. Populate configuration files. There are 7 configuration files here. First one, Hadoop -environment.sh. Under the file, you want to specify where Java is installed. Java's home path need to be specified here. And we have 3 XML files. One is core-site.xml. Second one is mappred-site.xml. Third one is hdfs-site.xml. These are all the 3 XML files. Under core-site.xml, you want to specify which computer is named node. Under mappred-site.xml, you want to specify which computer is designated as job tracker. Under HDFS, you want to specify the number of blocks, that is the number of block replica, whether it is a default 3 or 5 or any other thing, number of block replica. Okay. So these are all the 3 example files, and what you need to do, you have another 2 files. One is masters and another one is slaves. Under the masters, you need to specify which computer is secondary name node. Under slave, you want to specify the data nodes, data node 1 up to multiple data nodes. If you have n data nodes, the file contains all the things. So 1, 2, 3, 4, 5, 6, and another you have another. All these files will be present under the following location: under home, under Hadoop, under Hadoop-1.2.1, you have a folder by name conf. All these files will be present under the location. You have another file which is present under home, under Hadoop. .ssh. You have a file by name .ssh. Okay, so not on this ssh. Under home Hadoop, you have a file by name .bashrc, bash run control file. Okay, it is a hidden file. You open the file. Under the file, what you need, you want to specify 3 things. One is Java's home path, the location where you have Java installed. Second one is Hadoop home path, the location where you have installed Hadoop. And third one is class path for both Java and Hadoop. So the video will let you know where to look for home path, where to look for class path. The overview alone that I am providing now. Okay, these are all the informations that you need to populate on these configuration files. Totally, you'll be having 7 such files. So after configuring each and everything, what you need to do, step 8, you want to specify this bashrc file, command source .bashrc. That is to notify these configuration changes to Hadoop kernel. You want to do 2 things. Either you want to restart the server. Without restarting the server, if you want these things to be notified, the command is source space .bashrc. Okay. So these are, once everything is over, okay. So what you need to do here is, step, you want to format the name node. For the first time, you want to execute this command, format name node. So you want to move to the location cd home Hadoop / Hadoop-1.2.1, and you issue the command bin / Hadoop space name node space -format. Then it will format. you will get a message successfully formatted. First time alone you want to execute this command. Okay. So after that you want to start the service. Bin slash start -r.sh. If everything is configured, it will start name node, secondary name node, job tracker, data node, and task tracker. You can verify the same thing by simply typing JPS. It will list all these things. This is the way by which you need to configure your single node cluster. Okay. So I will share you the video of this single node cluster and the fundamentals that we have discussed now, and two videos on Linux. Okay, you please go through the video before coming for tomorrow's session. Tomorrow's session is at 8:30 a.m. We are going to start our discussion on Hive. Okay, so being I couldn't accommodate more than one batch on Saturday and Sunday, I had a plan to have a class from 8:30, 10:30, 11:30, 8:30, 9:30, to 11:30. 3 hours per day. Okay, Saturday and Sunday, totally 6 hours per week. This is my plan. So I am going to club the two batches. Now in this batch you have 4 peoples. Okay, so you have Kameshwar, and apart from that we have Gogul and 2 persons from US. And in our existing batch we have Deepraj, Dhanalakshmi, and 3 persons, Balamurugan, Vivekananda, Silver Star. Okay, all the 8 may be combined. So for this purpose, what I am going to do is, so I am going to merge the 2 batch. Tomorrow for the existing batch, Hive is going on. Then we have just now started Hive. Straight away we can move into the Hive. Remaining things that we have left out, multi-node cluster, Hadoop 2.x, will be taught to you in the forthcoming sessions for Kameswar and other. Okay, so here this is the way by which you need to configure the cluster. I will share the video of all the 3 things: Linux commands, single node cluster, and fundamentals. You please go through it before coming up for tomorrow's session. I will take a separate session for another 4 hours for you alone, for this batch alone. Okay.
Okay.
Okay. So as of what we have discussed up to now, is it clear for you?